Hey everybody, so we are looking at this problem maximum subarray. Given an integer array nums, find the subarray with the largest sum and return its sum. What does it mean by subarray? A subarray is a contiguous and non-empty sequence of elements within an array. Let's look at this problem. If nums is equals to this particular array, then the largest subarray can be 4 minus 1, 2 and 1, and that sums up to be 6. If we have something like nums and which is given as just 1, the output would be 1. We have to take this entire array. We cannot take empty as described above. Let's take this example 5, 4, minus 1, 7 and 8. In this case, we can take the entire array as subarray and the output would be 23. We can have a naive solution to this problem. We can find out all the subarrays of this array and take the largest sum possible. For that, we would have an algorithm in which each subarray would start from a point. So if it starts from minus 2, we have this subarray. We also have this element as a subarray. We have this subarray, this subarray. So we can do this for n numbers. We can start from any of these and we can create a total of n subarrays. So that would be an O of n square algorithm. This question is asking us if we can implement it in O of n, which means a single pass. Let's take a look at this example. The first subarray I can make would be minus 2 itself. So I can say that the largest sum I know so far, largest, is equals to minus 2. Now let's go forward and create a larger subarray. So let's take 1 into it. The cumulative would be minus 1. Is it larger than the largest we have? Yes. So it becomes minus 1. Let's move forward and take another element. Let's take minus 3. If I take minus 3, the cumulative becomes minus 4. Is it larger than the largest? No, it's not. So I'm not going to consider it. Let's move forward. I have this 4 over here, and that created a cumulative of 0. Is it the largest at this point? Yes, it is the largest at this point. So I can cut this and I say, okay, 0 is the largest I have seen so far. But there is something wrong here, you can see. What if this was my question, what if I just take 4? Then 4 should be my largest, right? It should not be 0 as we are getting over here. So we need to make one observation over here. This 4 alone can give me the largest. What is dragging it back? This side. It has a cumulative of minus 4. This 4 alone could have given me the maximum of the largest of 4 as the output. But this negative portion of the array is dragging down the entire sum. So, how about I say that I don't want to consider this negative? Very similarly, if we were looking at this subarray, this 1 would alone give me the output of 1. But this negative 2 is dragging that 1 down to negative 1, which means every time we have a negative value, can we say that this thing is just going to drag the entire output down? Just ignore it. So just take a look at the algorithm again. Minus 2 would be my first subarray. So minus 2 sum I have over here. So I can say, okay, the largest I know so far is minus 2. But since it is minus 2, I can also say let's keep a total which was minus 2 because we are looking at minus 2. And the moment we see minus 2, we basically say that this minus 2 will not help, it will only drag the next element down. So let's say if I get anything negative, let's ignore it and assign it to 0. I just don't need it. Let's move forward. This would be then the next subarray. We would not take minus 2. 1 is the next subarray. Is that larger than the largest I have? Yes, it is. Let's take 1. Then this expands. The total is also 1. This expands. 1 and minus 3. How much is this? Minus 2. Is minus 2 larger than the largest? No, it's not. I'm not going to consider that. But total would still change. Total would become negative of 2. I saw a negative value again, which means this part would also only drag things down. So all these three things combined are only dragging things down. So let's also ignore it and call it total equals to 0. Largest would be still 1. Let's take a look at this subarray. 4. Is 4 the largest so far? Yes, it is. Let's make it 4. My total also becomes 4. Let's take minus 1. 3. Is it the largest? No, it's not the largest. So we don't change this value. The total becomes 3. Why are we reducing this total? Why are we even taking this negative 1 when we know it's going to reduce the total sum? Because there is a possibility that the number over here is so big that it compensates for this negative value. So we continue moving forward in the hope of getting something larger. So let's move forward in this subarray. We have 2 over here. Is it the largest? We have a cumulative of 5. Is it the largest? Yes, it is the largest. So 3. This also becomes a cumulative of 5. Let's move forward. Let's take 1 into it. It's 6. So let's change 5 to 6. The largest is also 6. If I take negative 5, I am allowed to take negative values. How much is this? It's 1, not the largest, but the total would be changed to 1. I take another value 4. The total would be 5, but the largest would remain the same. So in this way, we can say that we found the largest as 6. So now this is the algorithm to solve this problem. Let's take a look at the code implementation. I'm here in the code editor. I have this function given max subarray and it has an input of nums. It returns the largest sum. The first thing I need is a variable to store the total. So I can say total and the assignment would be to 0. The next thing I need a variable to store the maximum total I have. So let's call it max total and this should be assigned to the minimum value negative infinity. Next I would iterate through the nums array. For n in nums we can calculate the total at every step. So I can say total equals to total plus n. Now this total may be the largest total. So let's say max total equals to max total or the total I have right now. Now this total over here can be the maximum total. If the value of total is less than 0, in that case I would like to reset the value of total to 0. So let's say total equals to 0, which means we found a subarray which has a negative value and we don't want to consider it in our final output. So we reset the total. In the end, I can just return the max total we have. So if I go through again, this would iterate through the nums. We would calculate the total at every step. If the total is less than 0, we want to reset it. But before we reset it, we want to make sure we are not resetting a negative value, because a negative value is also an answer. We can have a negative largest sum. So I want to consider it. This is the reason we are setting it to negative infinity and assigning its value before we reset total. Let's run this code. Let's submit it. So we have a solution.